Welcome back to another Code Meets World. Today we're going to be looking at the first problem in the bit manipulation section. There's a bunch of easy problems here, and a lot of you might be thinking, because I've been told the same thing, that bit manipulation isn't really all that important for coding interviews. A lot of people have said they've done dozens of interviews and this has never come up, but it's on NeetCode, so I'm going to go through it. And I learned some of this during my undergraduate curriculum, so I'm curious to see what I still remember. But this first problem is called single number, and we are given a non-empty array of integers where every element appears twice except for one. Find that single digit. So it's saying you must implement a solution with a linear runtime and use only constant extra space. And I'll talk about why that is a pretty restrictive requirement in a second. But let's jump down to the whiteboard here and talk about this. Okay, so let's look at these examples. It looks like a pretty straightforward problem because in this first example, there's two 2's and there's only one 1. So the solution should just be 1. And same with down here. The 2's, the 1's, they both have a pair. So there's 2 of them. The 4 only appears once. And that's the answer. And down here there's only 1. So that's the solution. So it's a deceptively simple problem. And what makes this tricky is actually what I just read in the instructions, which is that you can only use constant extra space. Because what I would do here, if this were any other problem, is I would probably just make a set, and I would add numbers to it as I went along. So I would add a 2. Actually, it would be better for it to be a dict, so we can keep track of the values, the counts of the values. So like with dict, I could put a 2 in, and then I've seen it once, and then when I see it a second time, I could increment this to 2. I guess you could use a set and add something when you see it the first time and subtract it when you see it the second time, and then at the end there's only one left. But either way, these ideas would work quite well. However, those do not use constant space. They use O of n space because it depends on how many values we encounter in the array. So this requirement to use only constant extra space means we have to do something with bits, and that's why this category is bit manipulation. So I think I'm lucky here because I think I remember how to do this. Let me explain. There are several bit operators, like there's the OR gate, the AND, oh that's terrible, ampersand, more like that. To all the electrical engineering people or those who know logic gates, I'm so sorry for screwing this up, but there's like the OR gate, the AND gate, there's like NOT for showing that something is not true. But then there's also this other one. I think the symbol is a caret, and it's called XOR. And this is called exclusive OR. And so the way that one works is if you have 2 bits that are the same, it produces 0. And that also works if they're non-zero. So if you have 2 bits that are the same, it always gives you 0. If you have bits that are different, you get 1. Or I think technically, you get whatever value is non-zero. It's something like this. But the way that this can work to solve the problem that we're working on, because until now it seems unclear how this would help us at all, I believe when you have, let me look at the second example here. So let me write out 4, 1, 2, 1, 2. We need to be able to return that the solution is 4. But what I think is if we XOR all of these values together, like this, I think we end up with 4 is our solution. Why do I say that? Because when 1 and 1 get XOR'd together, we see here that that gives us 0. Remember, anytime we XOR 2 things that are identical, we get 0. So when we XOR 1 and 1 together, we get 0. When we XOR 2 and 2 together, we get 0. So what I'm saying is I think this whole thing just goes to 0. And then when we do 4 XOR 0, I think it just gives you the non-zero value is the answer. And so it's 4. And this would solve the problem every time, because I think the XOR property is, and math people correct me if I'm wrong here, but I think it's commutative in the sense of it doesn't matter what order you have these values together. So like when you do 4 XOR 1, that, I'm not actually sure what that gives you, but the important part is it's commutative, right? I don't think it's additive. I think it's commutative, because we have these pairs in here, and if we just XOR everything together, it's the same thing as doing like 4 plus 1 plus 2 plus 1 plus 2. It doesn't matter what order we do these in, we could arrange it, whatever property of math that is, and it would work out. XOR is the same way. So because there are pairs in the stream, in the array, they're going to cancel each other out, and we're just going to be left with the value that we care about. So let's go ahead and try this. This would be awesome if it worked, because I think it'll also be really simple. So we can just start out with iterating through for each num in nums. We can say, I guess I need a solution variable. I'll call it solution. I'll set that equal to, I guess, 0 at the start. And we can say solution, I think we can just say equals solution, and then XOR is this question mark equals solution caret num. I think that's right. And then at the end, we just return solution. Let's try that. All I want to do is XOR all the values together. Oh, amazing. Yeah, that looks like it's correct. Can you also do this? You might be able to shorten it to solution without writing out solution each time. Same as like plus equals or times equals. Maybe it's backwards. Right, because like if we were doing times equals or something, it would be like that. So let's try this. Fantastic. Let's go ahead and submit. Yeah, fantastic. That worked. And it's really quick because remember, one of the requirements was it had to be really quick. It looks like you could do it with even less space, maybe if I didn't have the extra variable here. But yeah, that's how to do that in constant runtime, and more importantly with constant space, because I'm not using any extra memory other than the array itself and this single solution variable here. So I hope that was helpful, and I will see you in the next video.